All right, so this is a video lesson about the inverses of a function. So there's a couple of applications we use to do this, but this video is merely just to show you how to do the inverse of any function. Specifically, we're going to be looking at rational functions, polynomials, and radical functions. All right, so number one, for example. Notice how it says f of n equals 3 over n plus 2. So the goal is that we need to switch our x term and our y term. Meaning, the function, so f of n, that'd be considered a y term, right? Because that's the range or my output, whatever I get. And so and it says f of n, so n would therefore be my x term, okay? So for the purposes of this video, I'm just going to make them, when I do this, I'm going to call nx, and I'm going to call f of n y. Okay? So to find the inverse, we need to have x and y switch places. Okay? So this is going to be x equals 3 over y plus 2. All right, so that's the first part of how to find an inverse. Second part is, you need to solve for y again. Meaning, we have to get y by itself. But wait, y was already by itself. I know. But in order to find the inverse, you have to mix it up and then solve for it again. Okay? And so to get y by itself, well, I need to subtract 2 to the other side. Okay? So I have x minus 2 equals 3 over y. Now there's two different ways to think about this. Okay? I'm going to put an invisible 1 there. Because my students has gotten over this topic. That's why I'm going to do it this way. There's other ways, of course, you can do this, but here's the way that I would prefer. We can actually cross multiply here because we have two fractions equal to each other. And look at my beautiful butterfly. So that would give us y times x minus 2 equals 3 times 1 is 3. Now, before you say, well, wait, don't we have to distribute y into x minus 2? No, I don't. I'm going to leave them separate because I need to get y by itself, right? That's my goal. So let's just divide by x minus 2 on both sides. And I believe that's my answer. Y equals 3 over x minus 2. Y is all by itself, and there we go. All right, so that's one example. Let's take a look at number 2, for example, here. All right, so f of n, again, is my y term, because that's my output, or the range. And here n is my x term. Okay? So I'm going to switch places. That's how I start this. So it would be x equals negative y cubed minus 2. Now you might be wondering, wait, why didn't the negative and the cube move with x? So you just switch the variable. Everything stays the same. The negatives stay where they are. The exponents stay where they are. The only things that move are the variables. We're just switching those two places. All right. Now, in order to get y by itself, add 2. Okay. And that gives me x plus 2 equals negative y cubed. Let's divide by negative 1 here to get rid of that negative. And then that would be negative x minus 2 equals y cubed. And then I had to get rid of the cube. So what is the opposite of cubing something or taking something to the third power? The opposite of a third power would be a third root or a cubed root. And you do it to the other side. So the cube root and the third power cancel each other out. So I'm left with y equals the cube root of negative x minus 2. Now, students might say, wait, there's a negative inside a radical. That's bad. Well, I'll say two things. Number one, if we're not solving for y, like we're not trying to figure out y is 3 or y is 7. We're not trying to find a value for y. We were solving for y so that we can get the inverse of the equation of the function. So this is okay. Second of all, it is an odd root. So if it's 3, 5, 7, 9, negatives under the radical, already okay. But I'm not solving for y, meaning I'm trying to find a value for it. I'm just rearranging the problem. So negatives are okay under the radical. So that is kind of the gist of how you find the inverse of a function.